things you will know. The more you learn, the more places you will go. Keeping this as our motto for today, we, the NGC Club, is back again with an extraordinary webinar on load balancing. Our speaker for today, Sharma ma'am, works as an Azure Networking Support Engineer at Microsoft. She completed her BTech at 𝐿𝐥𝐿 University. She worked as a technical trainer at 𝐿𝐥𝐿 University, and also she was an SC intern at Microsoft. Now let's welcome her to enlighten us on load balancing. Over to you, ma'am.
Thank you for the introduction. And so let's start now. So Azure Load Balancer or load balancer is itself a very brief, very big and very vast topic which cannot be completed in an hour or in a tour. It requires experience and learning of months and years. So still I will try my best to complete as much as I can. And also I would request if at the end of session we all can turn on our videos if possible so that I can take a quick picture for that. Fine. So before starting, has any one of you worked on load balancer before or have idea about load balancer? Is there anyone? And also I just want this session to be interactive, okay? Because I was also in college. I know how I used to attend this session. Yeah, I was in your place earlier. But at that time also I used to ask a lot of questions because we get these opportunities very rarely. So I request all of you to use as much as you can. So yeah, again, I'm asking, any one of you have any idea about load balancer? Have you worked on that before?
Yes, ma'am. We had like load balancing. It's a topic where it distributes the traffic and workloads to ensure that no signal or a server is overloaded.
Yeah, true. Great. Thank you so much, Surya. I request everyone to participate as much as you can. So I'm sharing my screen for the PPT. Let me know once you can see it. I hope it's visible.
Yes, ma'am, it is visible.
Yeah.
Yes, ma'am.
So our agenda will be, we will discuss about virtual networks and IP addresses, load balancer, coming to the Azure load balancer. As I'm working in Microsoft, we work on Azure. Then we'll discuss about health probes. And at the end of the session, I'll do a quick lab for the understanding purpose. And let me know if I'm going very fast. So here comes virtual network. It is a very basic thing. I think you all might have known about it. So anyone quickly can share what is virtual network, what is network, or what is IP? So you guys are attending this webinar for certificate only, I believe. Or else you have no idea about virtual network. Guys, are you there? Fine. So virtual network or network is simply we are learning from our childhood. The connection or communication between the group of devices, group of nodes is a network. Like you are listening to this webinar, I am delivering this webinar. So what is on this between all is network. From your device to my device, everything happening between is networking. So this is the basic of network and virtual network. So within the flow of time, everything is going on cloud because it is necessary, it is important also. There are various advantages of cloud networking, such as it saves money, it saves times, it saves resources, it's secure in data, and also in case of any disaster, it is safe if each and every data is stored on cloud instead of being on a physical server. It is important also. So that is why we are switching to virtual network. So what is virtual network? It is nothing but collection of all these things, all these data, nodes, computer devices on cloud environment. I hope you must be aware of cloud environment. If not, please let me know. And then coming to IP. So yeah, IP is a 32 or 64-bit address which is attached to every computer or device. Because you might be aware of MAC address, which is attached to the NIC of every device. And of course, it is not internet routable. So that is why we have a picture of IP, which is internet routable. And through the IP, we can connect to any part of the world over cloud. So this is brief introduction about virtual network and IP. I wanted to give this so that you might not have any problem in the load balancing part. I hope you are clear about that. Guys, at least you can say yes or no. Hey Akshita, are you able to listen to me?
Yes, ma'am, I can.
Yeah, I can't see any responses from the audience. Am I going too fast?
I request everyone to on your mics and speak.
Yeah, you can also post it on chat. Anyways, it's fine. We are here to like gain something. In 1 hour, of course, I cannot teach you complete load balancer, but at least a brief if I can give, if you can learn a single thing only. If you can even learn how to talk, how to speak, how to present yourself in a webinar, that's also enough for this 1 hour session. Just don't attend it because you want to attend it, you want to gain certificates. No, guys. You guys are in college phase. I was there. I know what all things you go through, but take this as the opportunity to learn. No. Fine. Moving forward, load balancing. So, as its name suggests, load balancing to balance the load. That is why we have load balancer. It distributes the traffic to the backend poles efficiently. So, I will give you a real life example where load balancers come in picture. You must be aware of the big billion sale on Amazon, Flipkart. So how these things work when there is any sale on such OTT platforms, many of us we try to go and shop, almost everyone. So during that time we have a very high request, very high service running on those servers. So how to manage that? Sometimes it happen, the site may crash. And maybe you guys have also come across such factors where you must be joining any webinar and because of the heavy request, the site is failed. So in such scenarios, load balancers come in picture where it efficiently distributes the load to the backend pools according to the requirement. I know it's theory part, which a bit much difficult to understand. I am trained on it, so I know, but for the newcomers, it's difficult. So for that only, we'll do a lab. So quickly moving to the slide. Load balancer refers to efficiently distributing incoming traffic across a group of backend servers. So what are those backend servers? What is the load balancer? How it efficiently distribute the traffic? I will come across that in next slide. And let's see what it do. It distribute client request or network load efficiently across multiple servers. Whenever we are getting any client request, any request from us, suppose if we are searching anything on Amazon, I want a shirt. So this request, it goes to a load balancer. And from the load balancer, it efficiently send request to the servers, backend servers, which is available, which is up and running. Second point, it ensures high availability and reliability by sending requests only to the servers that are online, which is a must thing. So there are various backend servers running behind load balancer, but we have no idea which one is up, which one is running. What if the request goes to the server which is not healthy, which is not running? And this might result in reset of the communication and customer. So in this scenario, load balancer also ensures the traffic is going to the right server, which is up, which is running, and which is healthy. And it provides the flexibility to add or subtract servers as demand dictates. Truly. So what is cloud about? Cloud is about saving our money. So load balancer also do one thing. If the request is high, it deletes the servers because servers also require some space, it requires some money, and as per the demand increase it increase the number of server, so it has that flexibility also. So these are some of the few points where load balancer comes in picture. Now coming to Azure load balancer. So Azure, I think you guys are clear till that. And if you have any doubt, if I'm going fast, if you want to know anything, please stop me in between, guys. I request this. Should we go forward? Anything that you want to discuss in this slide? Fine, we're going forward. Coming to the Azure load balancer. So like every organization can have their own set of load balancers, such as we have in Azure. Azure is a cloud platform, and in Microsoft, we have Azure load balancer. Mainly, these are of two type, internal and external, but we will not go in that depth because, of course, it requires much amount of time. So load balancer, it basically consists of four components. If you have idea about those four components, then it's very easy to deploy any load balancer and backend pools. That is front-end IP configuration, backend pools, help ropes, and load balancing rules. So I will explain this with the help of this whiteboard. I hope it is visible. My whiteboard is visible, guys.
Yes, ma'am, it's
Yes,
visible.
ma'am. It is visible.
Yes, ma'am.
Do we have any question? Anything you want to see?
Yes,
Come on,
nothing else.
guys. Let's take this as an
And
opportunity to learn. No,
yes, ma'am. I'm sorry for
I'm
the
not just a
inconvenience.
mentor. I'm not a trainer. You guys can consider me as a senior who can help you. Yeah, fine. Moving forward. So how Azure Load Balancer works? Suppose just a second, guys. Fine. Suppose the traffic is coming from the internet. Like example, we have taken big billion days. From the internet, it want to access Amazon.com, which is here. It is there. From internet, one customer, it is trying to reach Amazon.com, and this Amazon.com is in these servers. Suppose this is virtual machine 1 and this is virtual machine 2. You guys know about virtual machine, is it? Guys, do you have idea about what is virtual machine?
Yes, ma'am, we have.
Yeah, nice. So suppose this is a virtual network. And inside that virtual network, we have two virtual machines which are deployed. For those who don't have idea about virtual machine, so virtual machine is nothing. It's a virtual environment that we create in which we can work, just like our PC, which we have physically. Same thing, same device we can deploy virtually. In lockdowns, what things were happening? We were not having access to our personal laptop, our company laptop. So at that time, how we were working? We created the virtual environment, same as our devices, where we can work online with high security and compatibility. So this is a virtual network. Inside that virtual network, we have deployed two virtual machines, VM1 and VM2. And this Amazon.com is one of the servers which is running in this virtual machine. Suppose from internet, one customer wants to reach Amazon.com. So how load balancer will come into picture and how things will go. So this is a load balancer. This is a load balancer. So whenever traffic is coming, what is happening? Firstly, it is going from here to load balancer, and now comes the picture of front-end IP. As I've already discussed in the slide, we have front-end IP configuration and back-end pools. We'll come into help probes later. So as soon as request will come, it will hit the front-end IP of the load balancer, which is also known as VIP. So every component which is online, which is virtual, it has some IP. That is how it can connect, it can communicate with each other. So as soon as request comes, firstly, it will hit the front-end IP, also known as VIP, of the load balancer. And from there, the request will go to the backend pools. These servers, what is all this behind? See, these VMs. This is nothing but this is a backend pool. Every machine which is running behind the load balancer is considered as a backend pool. From this load balancer now, the request will go to the backend pool. Fine. From this backend pool, and it will hit the dip of the backend pool. Now, what is dip? Just as the front-end IP of the load balancer is called as VIP, same the front-end IP, like the IP for which our VM is defined, for the IP for which the VM is routable on internet, that is known as dip. So from internet to the front-end IP, and from this front-end IP to the dip of the VM. Now question is how load balancer identify that which VM is healthy, which VM is up, which server is running. It's the VM healthy. If it is not healthy, then the request should go to this. If this is also not healthy, it will create one more VM. It is auto scalability that I've already discussed, and the request will go to that. So how all these things are identified by the load balancer? For that thing, we have something which is known as health probes. Fine. And load balancing rules, I will come when we will do a lab on this. So we have something for that. We have health probes, and load balancer usually works on two health probes, that is TCP and HTTP. And HTTPS, which is HTTP and HTTPS works same thing, and TCP is something which works differently. Again, coming to this. So when load balancer sends the data, before sending the traffic, it runs the health probe to see whether my backend pool is up or running, my backend pool is healthy or not. How? Let's see. Let's go with TCP first. You guys have idea about TCP protocol? I think you guys have heard about TCP. So as soon as request hits the load balancer, it sends, firstly, we are learning about health probes. So in health probes, we have two things, TCP protocol and HTTP or HTTPS. Fine. We have two health probes configuration, and by these things only, we'll get to know whether the backend pools are up, running, healthy or not. So firstly, let's discuss about TCP protocol, that how it identify whether it is healthy or not. From this load balancer, LB, I'm writing it LB. Request is going, suppose to this VM. It is like VM inside the virtual network, VM1, right? Request is going there. So suppose if the customer has configured the load balancer for TCP health probe, it is up to us, like for what we need to consider the health probes for. So if we have considered it for TCP, then how it checks the compatibility? Firstly, it will send the, I think you might have aware about it. Firstly, it will send the acknowledgement packets to the server. Fine. Just a second. This is client and this is server. So how TCP help ropes work? Firstly, the client will send the acknowledgement, sorry, not the acknowledgement packet, my mistake. SYN packet. Firstly, the client will send the sync packet to the server. What does this sync packet mean? Sync means synchronization. So there is a synchronization between client and server. To establish that, firstly, it sends this packet. From server side now, it will come SYN plus ACK. SYN, which means synchronization. Yes, I have accepted your synchronization and I have acknowledged that. So from client to server, it will send sync. From server to client, it will send sync plus acknowledgement. And again, the client will send acknowledgement packet. That fine, I have received your acknowledgement. Now I will establish relationship between you and me. So by sending all these three packets, a channel, a tunnel, a link is created between client and server. And this is how LB gets to know this, yes, this VM is fine, up and running. And then from the internet, it will send request to this packet. Fine. Now suppose if customer or the client doesn't get this same packet, which means the TCP help ropes are not working and this VM is not healthy. Now again, this LB will send the request to another VM. Again, these three things will happen: SYN, SYNAC, and ACK. If it is working, then it will send request to that VM. So this is how TCP help ropes work. Am I clear with that, guys? Are you okay with what is TCP help ropes? And also when we do the labs, no, we come across these all scenarios. So I think you will be more clear on that thing. Again, I'll brief it. So whenever any request come to LB, it goes to the backend pool. So to identify that backend pools are healthy, up and running, we have help ropes mechanism. And in help ropes, we have two protocols, which is TCP and HTTP, to check whether the backend server is healthy or not. I just discussed TCP protocol. In TCP protocol, there is a communication between client and server, and we send three packets. First is the SYN packet synchronization, second is SYN plus ACK, and the third one is acknowledgement. So this is how communication happens. So this was about TCP protocol. Now we'll come towards the HTTP and HTTPS protocols. Give me a second, guys.
Guys, if you have any queries, you can raise your hand so that ma'am can answer them one by one.
Yes, also we have enabled the chat box option, so you can keep your queries over the chat box also, and the mic is disabled. So if you want ask anything, so keep stay your hands to be raised. So we'll enable the mic also.
Yes, guys, feel free to answer. I know this, if you are new to this load balancer thing, it is difficult for you to understand at a one time, but that's why I'm keeping it very easy, very normal level, so that you guys can have a clear or a little idea of what is happening. Yes, I think someone raised their hand. Please tell me.
Hello, ma'am.
Yeah, please tell me.
Ma'am, what is backend pool, ma'am?
Yeah. So backend pool is nothing but the servers or the virtual machine to which the request is sending. Normal language, I'll tell you. Suppose from your computer, you are searching a good t-shirt on Amazon. Fine. So if you press enter, then how your request is going, where your request is going. So from there, your request is going to a group of servers. From their server, you are getting some response. So those group of servers are known as backend pools. These servers are kept behind the load balancer. That is why it is said to be a backend pools. I hope you're clear. If not,
Yes,
I'll
ma'am.
explain again. Just feel free. As many times if you want, I can explain it. It's clear or not?
Yes, ma'am, it's clear.
Yeah, okay, fine. So till now we have learned about TCP protocols. Now it's come to HTTP protocol. So how, with the help of HTTP protocol, we get to know that the server is healthy or not. In TCP protocol, we focus on these three things. If we are getting these three flags, we call them as flags. If we are getting these three flags, which means yes, fine, it is good to send the data. Now let's come to just a second, guys. HTTPS protocols. So how in this it works? So it is very simple mechanism. We generally prefer this. In this, we send the request from server, from client to server. And in this scenario, server should respond with 200 OK response, which means from the load balancer, we are sending request to the backend pool, and backend pool should respond with 200 OK response. From this in the screen, it should be 200. If it is responding with 200, which means yes, backend pool is fine. If not, then what happens? Sometimes I think you might also come across 401 error. Sometimes we get 401 error when we do something on Google. So why it is getting in this scenario? Because that server is not listening to the help probes and it will return this error. Sometimes we get 403 error. These are very common errors. While working on Google or Bing, anything, we get these error. So why this is getting? Because those backend servers are not working. Maybe there is not any service listening to this on the server. Maybe any machine, any thing is not working on the server, and that is why we get these error. So in HTTPS protocol, simply remember one thing: from client to server, we send the message probes, and if the server respond with 200 OK response, which means yes, our help probe is up and is working, and we are good to send the data. Simply, but generally in this scenarios, we generally prefer TCP protocol because it is fast and more reliable also. So this is all about help probes. So we came across front-end IP configuration, done. Backend pools, done. Help probes, done. And then finally it comes to load balancing rule. So we have defined the front-end IP. Okay, fine. This is the front-end IP of my load balancer. Then backend pool. Okay, fine. These are my backend pools. These are my backend pool IP. Fine. Help probes. This is my help probe. I have configured for TCP or I have configured for HTTP. Now to combine all these things, we have these things. Suppose in a birthday party, we want to gift something. So we purchase gift wrap, we purchase that gift, fine. But now we have to combine all these things. No. So to combine all these things, we have load balancing rule. We apply all these load balancing rules and we apply all these things to our network. So this is a theoretical thing, which is difficult to understand. I know. So now we will come to lab. In lab scenario, what we will do, we will create two VM. Fine. In a virtual network, we will deploy two VM. Then we will create a load balancer. We will put these two VM behind this load balancer, and then we will check the connectivity, that we have the connectivity or not. Fine, guys. And yeah, anyone who have worked on Azure before? Anyone who have worked on Azure? Yes or no, guys? You can say yes or no. It's fine. If you have not worked, it's fine. In my college days also, I have no communication with the Azure part. It's fine if you haven't worked on Azure. It is a session to improve your interest on these things. If you have interest in future, you can also contact me via LinkedIn. So these sessions are originally done to improve your interest in such areas, because it's true in an hour we cannot get any clear idea of any one topic. So I think no, you have not worked on Azure before. So Azure is a cloud platform where we can create our own environment to work, where I can create my own machine. Machine here, virtual machine means our own laptops thing that is virtual. we can create our own load balancer. We can communicate between them virtually. So Azure is that platform. So what we will do, we will create two virtual machine. We will create a load balancer. We will put those virtual machine behind the load balancer as a backend pool, and we will check the communication. So I'm doing it now. I hope you can see my Azure portal. This is the Azure portal that we have. Fine. Firstly, we'll start with creating a virtual network because you guys are new. I'll start from scratch. Otherwise, I was thinking of showing it virtually. I already have load balancer. I already have VM. But because you are new to Azure portal, firstly, we'll create a virtual network. Create option. We'll give any name. Suppose we'll give test. And we have to select the region also. Like in Azure, what we have specific region, and we can deploy our virtual machine, our virtual network on any specific region. See, there is a list of region where we can deploy. But I generally prefer to deploy my machine in East US region because here the communication is a bit more fast and easy. Next, we'll leave everything by default. Now IP addresses. So every virtual network has a range, as a group of IP addresses. So my range is 10.0.0.16, which means total I have these many addresses. In my virtual network, I can deploy these many machines. Fine. Here comes the IP part, and I will create a virtual network, which name is test. Great. See, it is deploying. It will take little time. And also as a student, you can also get access to the Azure platform. For students, it's like free for a month or two. So if you apply, you can also work. You can also get some hands-on experience on deploying a virtual machine, deploying network. So this is the virtual network that we have deployed. Now in this virtual network, we will create two virtual machine. So we'll click on virtual machine and we'll create. We'll give any name, suppose test 1. And I'll select the Windows Server 2016, which means I am creating a virtual machine of Windows 16. And username, just as we log into a computer, we have some username, we give some password. So for this also, virtual machines also, we need to give some username and password. Suppose I'm giving it as Shailza and any password. That should be strong. Fine. Next, we will go to this networking portion. Now it's this thing here, virtual network. We need to select in which virtual network we need to deploy our VM. Suppose I have VNet 1, VNet 2, but no, I want to deploy my virtual machine in test virtual network because I have created it just now. So I will choose this test. Rest we will keep it as default and we will create a virtual machine. Side by side, I'll also deploy another virtual machine because we need two VM in our backend pools. So we'll create. It is creating, it will take a minute or two. Till the time we can also create another virtual machine. I know it is a bit overwhelming, but if you can try hands-on experience on this, I will suggest it will be much better. So second VM will give it as test2. We'll keep everything as default. Images C, Windows Server 2016. Username, again, I can give any username. I'm giving Shailza only. Next is networking. I will select test only. It is test by default, and I will create it. Till the time it is in deployment. This is my virtual network. This is my VM1 and this is my VM2. Now we will start deploying our load balancer also. Let's see it is deployed or not. See, my VM1 is deployed. And now we will do one thing. We will connect to our machine. See how we connect. In the overview portion, we'll click on connect. We'll do RDP. We'll download this RDP file and we'll open it. See, this is my VM1. I have created a virtual environment to work. This is how we can create a virtual environment. This is my VM1, and as it is a Windows 2016 data center, so it have that configuration only. See, same we'll do it with VM2. We'll connect, we'll do RDP, we'll download this file, we'll open this. And we'll do one thing. Now what we have to do, we have to also configure our virtual machine for the server role. This is the virtual machine, but we haven't configured any server for it. So firstly, we'll configure this for server because that is how we need to access, no? So we'll add role. It will take time to load. It is getting loaded. Till the time, we'll do one thing. We'll create a load balancer. So yeah, here it is. So what is the name? We'll give test LB. Okay, name of the load balancer is test LB. I think it already exists. Yeah, this is also the thing. We cannot repeat the names. So test LB1. Fine. Next, here comes the front-end IP. As I've already said, now we have front-end IP. So we'll give any front-end IP to the load balancer to which the request can come. We'll give any name. Suppose IP I'm giving virtual network test. So from test virtual network, it will take any front-end IP and it will assign to that load balancer. Subnet, I'll keep it as default and add. So now first part is done. We have added the front-end IP. What is the front-end IP? The IP at which the request will hit the load balancer. So now the request will hit to this front-end IP. Next come the backend pools. Now we will add our VMs at the backend of the load balancer because our VMs will act as a server. So for that we need to add our backend pools. We'll give any name. Suppose pool I'm giving. And with the help of IP addresses, I will add. What is the name? What is the IP of my VMs? Let's see. In the overview portion, we can see here. This is the IP address 10.0.0.4 for test 1, and for test 2, the IP is 10.0.0.5. So in the backend pool, I'll choose this and I'll choose this and I'll save it. So now backend pools also done. Frontend IP done. I have added the frontend IP. Backend pools done. I have added the backend pools. Rest everything, I'll keep it as default and we will create it. Now I will also tell you about health proofs. Till the time it is getting deployed, we will do one thing. We will configure our VMs for server role, because behind the backend pools, they're acting as server only. So quickly we will do this as server role. And also guys, the public documents, see, web server IIS, we will configure it for web server role. We will add the feature. And the public document for all these things are available from Microsoft only. It is available. So you can also check these things if you have time and if you have interest in this. So I have configured VM1 for this. Now test2 VM also I will configure for web server role. I will select this, add feature, next, next, and install. It will take little time. Fine. Till the time we will check our load balancer. So we have configured our VMs for server and we have put that behind a load balancer. So now what will happen if we try to access the front-end IP of the VM, of the load balancer? According to you guys, what should happen? So whenever we'll try to access the front-end IP, the request should go to the backend pool and it should come as a web page, because we have configured our VM as a web page, web server. So whenever we'll try to access the load balancer front-end IP, it should redirect us to the web page. We will see if it is happening or not. Fine. Before that, are we missing something, guys? Front-end IP done, backend pool is done. What are things we are missing? Anyone? Anyone, guys? We have done the front-end IP, we have done the backend pools. What two things are missing in our load balancer portion? Coming to this slide only. See, front-end IP done, backend pools done. Now health probe configuration is done, is left, because if there is no health probes, how the load balancer will check that whether the test 1 or test 2 is available or not? And to combine all these things, we have load balancing rules. वो तो हमने define किया ही नहीं. We have not defined that. So we'll come to the health probe. You can see this is our load balancer. Front-end IP done, backend pools done. Now health probes. We'll add a health probe also. Name we'll give any name, suppose probe. And see, here we have option TCP, HTTP or HTTPS. Now here we can select that which health probe we want to configure. So suppose I want to configure for TCP health probe and port 80. Now what is this port means? So the request will go to the VM. As I said, from client to server, request will go, but where it will go? So we have defined port 80 of this VM, request will go, and interval 5 seconds. What does it mean? Which means after every 5 seconds, load balancer will send the request to check if the server is healthy or not. If server is healthy or not, after every 5 seconds, it will send the request to check it. So now we have also added a health probe for TCP protocol. Now only one thing is left, that is load balancing rule. We have defined IP, we have defined backend pool, we have defined health probe, but we will combine all these things, and this combining is known as load balancing rules. See, load balancing rules, we'll add rule name, we'll give any name, suppose rule. Content IP, this we have already defined. IPC, IP I have given the name. Backend pool is pool, I have configured backend pool. And port is 80. We'll keep every port as 80, which means request will go to port 80 of every VM. And see, health probe is TCP we configured, and we'll save it. Now, all the things that we have configured, be it IP, be it pool, be it health probes, we have combined all these things with the help of load balancing rule. This is the rule we have created. Fine. We'll also check our VMs now. See, it is done. This one, it is also done. So now how we will check the connectivity, what we are actually trying to check. So we are trying to check whenever we will, what is the IP? This is the IP. Whenever we will try to connect to this IP, it will take us to the backend pool, and our backend pool is a server. So we should be getting any web page. Again, I'm saying what we are trying to connect reach is, this is the load balancer. This is the load balancer front end IP. From internet, this is my internet. From internet, I will try to ping this IP and it should reach to the backend pool. And as a backend pool is a web page server, so it should take me to a server. Let's do that. This is my internet. I will bring this IP. Sometimes it will take time. Not happening. Just a second, guys. Let me check what is the configuration issue we are getting. So it is not happening. What does it mean now? It is a real life scenario happening in front of you. So what does it mean, guys? Suppose we have to get a web page here. Instead of this, we are getting this error. What may be the issue regarding this? Just now we discussed, and here comes the real life scenario also. I had to deploy something. I had to redefine these things, which will take time. So I'll not go there, but I will tell you what will happen whenever I will try to ping this IP, front-end IP of the load balancer. It will take me to a web page because I've configured my VMs, my backend pools for a web page. But in this scenario, it is not happening. So why? Because it may be because of any of those reasons. that I have discussed in this slide, that the health ropes are not working at that point. Maybe any services is not listening to those VM. So this is the thing which can happen, and the real life scenarios happen itself also here only. But if everything was fine, we will get to our web page. We don't have much time now, otherwise I must have shown you here itself, because at 12 I have a pre-scheduled call which I cannot miss. So this is from my side, from Azure Load Balancer, which is very brief thing. Still, it is overwhelming, I know. But if you want to go in depth on this, we can also have another session later. Till the time, if you have any question, any doubt, please tell me. No response from this batch.
Nothing else, ma'am.
Yeah, only Surya is listening, nothing else. No one is listening. So guys, this topic is really vast. Cloud is really vast. Apart from these technical stuff and things, you guys are from which field, like CS or EC or mixed? Which field you guys are?
Mixed, ma'am.
Yeah, fine. So which year you guys are in? Second, third, fourth?
We were already all combinedly, ma'am, second year and third year.
Okay, so this college thing is a very crucial time of your life, and I would suggest this cloud thing. It's like a vast thing which is growing a lot. So if you guys have interest in these cloud things, I suggest you to not waste your time, because when I was in college, we were not having any proper guidelines, we were not having any proper communication where we can get these things from. But if you guys are getting such opportunities, your club, your college is really nice to attend, to host such events. So where you can get a little thing, little idea. Today's session, maybe you are not able to understand anything, but still a basic idea of how Azure work, how load balancer work. If this is also fine then. So I suggest you guys to explore more, to see more, not only via this session, but go online. Instead of scrolling Instagram, you can go online, you can search few things. It will eventually help. And as per my expertise, this cloud thing is really exploring and glowing. So if you guys have interest, then follow your interest and you can learn from these things. And also in future, if you have any problem, any help, if you want anything from my side, feel free to ping me on LinkedIn. I'm easily available with my surname, Shailza Sharma, and you can easily get me. Anything else you want to see from me, guys? Talking to college students is really fun for me, because I was also in college few years back. So it is really nice to see you all, guys.
Ma'am, once can you turn on your camera so that we can take a picture?
Yeah, sure, I will turn on, but my condition is like everyone should turn on, no? Why only me? I
Yes,
already
ma'am.
requested it.
Yes,
I'll
ma'am, and I
also
request
I'll also take a
everyone to
picture,
turn on
because
your
I will post
webcam.
it on my LinkedIn. So yeah, I request all of you to turn on. Come on, guys, you guys are in college. Why too shy? I was also in college few months back. It's all fine. I hope I'm visible. Hello, everyone.
Yes, ma'am. Hello.
I request everyone to turn on your webcams, please.
Come on, guys. Why you are shying so much? I'm also a kid like you only. See, not a professor, not a teacher. I only see Surya, no one else.
Yes, Akshita and Shravya, Mrudula, you guys also please turn on your camera because the presenters should be turned on must. So those who are interested to turn on your webcam, please, from the attendees.
They don't want to.
Yes, ma'am. Actually, as it is a holiday, they might be in normal dressing sense, so that's why they are not going to.
So what? I'm also in a normal dressing sense. I'm not wearing anything proper, no. See.
Camera
Fine.
is not enabled for the attendee.
Yes, Akshita.
Fine, leave it, guys. They don't want to show their faces.
Yes.
Yeah, someone came and just vanished. Who
That's
was
our
that?
host, Akshita.
Then host itself is not there, and you were expecting me to turn on my video. Wow, great guys.
I'm so sorry. I'm not in a proper
You were
dressing sense.
looking pretty. Please turn on.
Come on, guys. Ma'am is running late. It's already becoming 12.
Yeah, true. Yeah, Anusha, screen is black. I cannot see her. Leave it, guys. I'm just clicking a picture for myself for as a memory. You guys don't want to, right? That's it. Thank you everyone for inviting me. It was really nice interacting with you. It would be might better if there was a less more interaction, but it's fine. In future, if you want anything, any help, I'm available on LinkedIn and we can interact much. Thank you so much for having me here. Good day, guys. Bye.
On
Yes,
behalf of
ma'am.
entire
Thank you.
NGC Club and VTP, I would like to thank our honorable speaker. Thank you, ma'am, for inspiring and encouraging us with your words on this special day. Thank you so
Thank you,
much, ma'am.
everyone. Bye bye.
Yes, ma'am. Thank you. Have a nice day.
And also, if you have pictures, send me, okay?
Yes, ma'am.
Yes,
Sure,
ma'am.
sure.
Yeah, okay.